All right. Hey, everybody. Welcome to the Week 20 Test Key. Let's get started. First question asks me to express 160 degrees in radian measure. So to do that, I have to take 160 degrees. So 160 degrees. I'm going to put it over 1. And I'm going to multiply it by pi over 180 degrees. And this way, my degrees can cancel out, and I'm left in radians. So going back to this is going to give me 160 times pi, which is just 160 pi over 180. And then I'll simplify that. Let's see. I can factor a 10 out of both and cancel those. So that would become 16 over 80 if I divide them both by 10, or 16 over 18, rather. And then I can divide them both by 2. So 16 divided by 2 is 8. 18 divided by 2 is 9. So we wind up with 8 pi over 9, which is answer choice number 2. Next up, if the measure of theta is negative 50 degrees, which is the correct position? So this looks like a positive 50 degrees, probably. If this is 50, that means this angle would be 130. If this is 50, well, that's just not right. Yeah, here we've got a reference angle of negative 50 degrees because we could rotate that way and get to it, 50 degrees. All right, next up, we know that theta is negative pi over 3, and it's asking me for the value of my y coordinate. So the first thing I'm going to do is figure out what this is in degrees. So I have, let me think through this here, negative pi over 3 radians. So I'm going to multiply that by 180 degrees over pi. That way the radians are going to cancel out. The pi's will cancel in this case, and I get negative 180 over 3, which is going to be approximately, or exactly, I should say, negative 60 degrees. So this is negative 60 degrees. I know that my y coordinate here is going to be negative. And I know since this is negative 60, I could just go ahead and plug that into my calculator. Why don't I do that? I'll do it that way for you guys. So if I open up my calculator here, I'm going to have to make sure that I'm in degree mode. So I'll go to mode. I'll move it from radians to degrees. And then I have to do the y coordinate. So I know y is going to be sine. So I have to do sine of 30 degrees, or excuse me, sine of 60 degrees, which gives me this. So it's going to be negative 0.866 dot dot dot. And that is approximately equal to, and I can check these, the square root of 3 over 2 gives me the same thing. Good. So that means that it's answer choice number 1. Here it's asking me to rationalize the denominator. So in order to do that, I need to multiply by the conjugate of the numerator. So the conjugate of the numerator is 3 minus radical 3 on top and 3 minus radical 3 on bottom. My favorite thing to do with the numerator, I'm not even going to bother to distribute it in because I don't know what's going to happen later, and it'll maybe save me some work as I'm canceling things. And for the denominator, I'm going to be careful here. So 3 times 3 gives me 9. 3 times negative radical 3 gives me negative 3 radical 3. This would be plus 3 radical 3. And then this would just wind up being minus 3. Because radical 3 times radical 3 is radical 9, which is 3. These are going to cancel out, this negative and this positive 3 radical 3, so I will get 12 over 9 minus 3, which is 6. And this is why I simplify this. I can go ahead and divide both of these by 6, so then this would basically cancel out, and this would become a 2. So I wind up with 2, 3 minus radical 3, which is equal to 6 minus 2 radical 3. Either of these are totally acceptable answers. And now I'm just going to make sure that these are the same thing. So I'm going to take my original expression right here. And I get it as a decimal. And then I'm going to take my new expression, 6 minus 2 radical 3. A little too fast there. And I just need to make sure that those two are in fact the same. And it looks like they are. 2.53, and this is 2.53. So sure enough, we're in good shape. All right, number 5, it's asking me to go from 1.2 pi radians to degrees. So we have pi radians in 180 degrees. So that means in this case, radians cancel with radians, leaving me in degrees. And this pi is going to cancel with this pi. So I just wind up with 1.2 times 180 degrees, which is equal to, let's try this. 1.2 times 180 degrees gives me 216 degrees. And there we have it for number 5. Number 6. In a circle, there is a central angle that intercepts an arc of 12 centimeters. So if I were to draw it for you guys, I have a central angle in an arc of 12 centimeters. The radius is 6 centimeters. So this is 6. My arc here on the outside, I'll do it in a different color. I'll do it in blue. My arc here is 12 long, and it's asking me the number of degrees in this angle right here. So I know that if the radius is 6 and I've got 12 inches around, this is going to be 2 radians. Or if I were to use the formula, I could say the length of the arc, or S, this is my arc, equals theta, which is my angle in radians, times r, which is my radius. So if my arc is 12, that's going to be equal to theta times r, and r in this case is 6. Divide both sides by 6, and I get theta equals 2. So I've got 2 radians. Should make sense. All right, time for a little bit of algebra. So to save myself some time, I am just going to copy this thing and paste it down below. All right. You know what? I'm actually going to do this in pieces. I wonder if this is going to be worth the time I'm about to spend on it, but let's try it. So here I'm going to give myself some space to do this problem, basically, is what I'm trying to do. Minus that equals this. Okay. And then, of course, I've got my equal sign. So the first thing I'm going to do is factor this guy. Or I guess I should do it here, because that's where I said I'm doing my work. So I'm trying to find numbers that add to -1 and multiply to 12. So I'm thinking 4 and 3. So it'll be x minus 4 and x plus 3. And hey, that's convenient. So all this needs to be the same as an x plus 3. Because this is subtraction, I'm going to change this to a plus and this to a minus, because adding or subtracting is the same thing as adding a negative. And then all this needs is an x minus 4. Now all my denominators are the same, so I can ignore them, and I will distribute. So this becomes x squared plus 3x minus x plus 4 equals 28. Combine my like terms, I get x squared plus 2x plus 4 equals 28. Subtract 28 from both sides, and I get x squared plus 2x minus 24 equals 0. So now I'm looking for two numbers that add to 2 and multiply to 24. So factors of 24 include 6 and 4. Those are 2 apart. I think that's right. Yep, 6 and 4. So it's going to be x plus 6 and x minus 4 equals 0. So my solutions will be x equals -6 and x equals +4. Now I'm going to go back and check this. I see immediately that this is extraneous because when I plug the 4 into the denominator here, I would get a 0, and I can never have that. So this is an extraneous solution. meaning this is my only answer. All right, equation of a circle. So I'm going to take the center of the circle and I'm going to flip the coordinates. So I get x plus 5 squared plus y minus 3 squared equals my radius squared. So now I need to solve for radius squared. So I'm going to make a right triangle. So I know that this side is 1, 2, 3, 4 units long, and I know that this is 1, 2, 3, 4 units long as well. Cool. Yeah, that works out nicely. So I can set up a Pythagorean theorem thing. This is my radius, so I can say 4 squared plus 4 squared equals the radius squared. So hey, once I know what 4 squared plus 4 squared is, I will have my radius squared. 4 squared is 16, so I get 16 plus 16 equals r squared, or 32 equals r squared, so then I can just substitute that in. So I get x plus 5 squared plus y minus 3 squared equals 32. And that is my final answer for this. X plus 5, y minus 3 equals 32. All right, which of the following is equivalent to this difference here? All right, so I've got a common denominator, so I can actually just kind of rewrite this. I have to keep in mind that when I'm subtracting, there's like parentheses around there, and I'm going to need to distribute this negative sign. So I can rewrite this as x minus 2x minus 8, or I should say x squared minus 2x minus 8, because I just distributed this, so it becomes a negative 2x. I distributed this, so it becomes a negative 8, over my common denominator, which is 16 minus x squared. I can rewrite this as x, well, I'll go ahead and factor them both now at once. So I'm looking for numbers that add to negative 2 and multiply to negative 8. Okay, multiplying to 8, 4, and 2. I think, yeah, that's the way I'm going to go. So I'm going to go with a negative 4 and a positive 2. So then I get 4 plus x and 4 minus x. Okay, then I notice I have an x minus 4 and a 4 minus x, so these are going to cancel each other out, and when that happens, I'm going to get this negative 1 that emerges because they're flipped versions of each other. They're not quite the same, but they're close. So the negative 1 is going to come down along with this x plus 2, and of course the 4 plus x, I see x is first in all my denominators, so I'm just going to rewrite it as x plus 4. And so this looks like it is most similar to answer choice number 1. We could write it with a negative out front, the x plus 2 on the top, and the x plus 4 on the bottom. Number 10 is asking for a solution here. So first I'm going to see if it's possible to add and multiply to 4 and 6. So things that multiply to 6 are 6 and 1. Those can't add to 4, and 3 and 2. Yeah, those don't work either. So I guess if I want solutions here, I'm going to have to use the quadratic formula or completing the square. I'm going to complete the square. I think it'll be fun. By the way, the reason I'm going to complete the square, just to slow down for a second for you guys, I know it's going to be doable because 4 here is even, so when I divide that by 2, I'm still going to have an integer. So let's subtract 6 from both sides, and then I get x squared plus 4x equals negative 6. Now, I'm going to divide this by 2 and square it. So 4 divided by 2 squared. 4 divided by 2 is 2. Square that, I get 4. So I'm going to have to add 4 to both sides. This is going to factor into x plus 2 squared, and this is going to become a negative 2. Alrighty, let's keep going. So I'm going to square root both sides. Those cancel, so I'm going to get x plus 2 equals positive and negative, the square root of negative 2. I'm going to subtract 2 from both sides, and I get x equals negative 2 plus or minus, and then the square root of negative 2 is going to be, well, I radical 2, because this negative is going to come up. So I get I radical 2. And that should be my solution. I'm feeling a little nervous, so I am going to check that answer, and I will be right back. Great, I checked it. Looks good. All right, on to number 11. So domain and range. Domain, well, this is going to be my x values, range is going to be my y. So my minimum x value looks like it's right here at -5. And there's a circle, so that is a parenthesis, not a bracket. Then my maximum is going to be at -2. My minimum range value is my minimum y value, so that's down there at -4. And my maximum is going to be all the way up here at +4. That's the domain and the range of the graph. All right, 12. To do this, I have to take 2x plus 3, and I have to set it equal to 7. And I'm going to take 2x plus 3, and I'm going to set it equal to -7 because it's in those absolute value bars. Subtract 3 from both sides, and I get 2x equals 4. Divide both sides by 2, and I get x equals 2. That's one solution. Here, if I subtract 3 from both sides, I get 2x equals -10. Divide by 2, and I get x equals -5. So my two solutions are x equals 2 and x equals -5. They have to be open circles because this guy right here is just a greater than, not an equal to. So they're open circles, which means this guy is out and this guy is out, so I'm between these two. I see that I've got a -5 and a +2, so it looks like answer choice number 2. It's a greater, so generally that means I'm shading outward, so I'm feeling pretty good about that. And I can always graph it to check. So if I pull up my graph here, let's see, I gotta open up a new calculator because that one's frozen. Kind of glitchy software here. Then I'm gonna go in here, I'm gonna go to math, I'm gonna go to absolute value, and I'm gonna do 2x plus 3 is greater than 7. So greater than is option number 3. And sure enough, it looks like I'm shading out, and it looks like I've got a +2 right here and a -5 right there, so I'm feeling good. All right, 13. Here it's asking me for the coordinates of x and y, so it's asking me for the measure of JOY. One thing that I'm noticing is that my x and my y coordinates are the same. They're both radical 2/2. So I know that that means that this must be an isosceles right triangle because the two sides are the same. So if this is 90, this has to be 45, and this has to be 45. So I know that this is a 45-degree angle right there. All right, finally, let's simplify this thing. So I've got the cube root of 128 times the cube root of x to the 6th times the cube root of y to the 5th. So I'm going to break this apart and I'm going to look for groups of 3. So 128, let's do it. 128, I know it's divisible by 2, so that gives me 64 times 2. 64 I know is going to be equal to 8 times 8, and I know that each of these are going to be equal to 2 times 4, and I know that each of these 4s are equal to 2 times 2. So I really have a lot of 2's coming out of here. Let's see how many groups of 3 I can get. So I am going to have, I'll switch colors, a group of 3 2's right here. I'm going to have a group of 3 2's right here. And then I'm going to have this extra 2 hanging out. So this is going to be rewritten over here. I'll move it down a little bit as 2 times 2, because each of these groups become a single 2 on the outside with a 2 in the middle. Over here now, I'm looking for groups of 3, so if I were to actually draw it out, I'll use black just to be consistent with my color scheme here, very important things. I'm going to have 6 x's, and I'm looking for groups of 3. So here's one group of 3, here's another group of 3. So this is just going to be written as another x times an x, not in the radical. They both broke out. And here, same deal. In black, I'm looking for groups of 3, but I'm only going to have 5 y's. So I'm only going to be able to get one group of 3 out. So I'm going to be able to break one single y out, and I'm going to be left with 2 y's on the inside. So that's going to be a y squared on the inside. Okie doke. So now I'm just going to do a little math. On the outside, I see I have a 2 times 2, which is a 4. I have an x times x, which is an x squared, and I have a y. Then on the inside, I'm still going to have the square root of 2 and a y squared. So I'm almost positive that this is my answer, but just to be sure, I'm going to pick some numbers and check it. So I'm going to take 8, and I'm going to store that number in x. I just picked 8 kind of randomly. I'm going to take, I don't know, 5, and I am going to store that in y. So I'm going to store that in y. And then I'm just going to make sure that these two give me the same number. So if I do the cube root of 128 x to the 6th times y to the 5th, it gives me that crazy number, all right? And then I'm going to do the same thing for my simplified expression, and they better give me the same crazy number. So actually, before I even have that, I'm going to have a 4x squared y. Then I'm going to have a, not a square root, but a cube root of, ooh, good catch, these are cube roots. See, this is why I do these things. This is why it's important to check your work. So that should be a cube root right there. And to be very clear, that's a cube root. It's not y cubed. So maybe I should even rewrite it a little clearer, but I'll do that in a minute. And then I have this cube root. It is kind of hard to see the distinction. It even looks like that's with the y there, but it's not. And then I'm just going to have a 2y squared. And I'm going to pray that gives me the same crazy number, and sure enough it does. So there is my check. I know I am good. Alrighty, so that is it for this test, I believe. Yeah, that's it. So have a, well, yeah, good luck with it. I was about to say have a great day, but that doesn't really make sense in this context. So good luck with everything, and I will see you guys very soon.